Okay, so guys, what I want to do is I want to talk with you about what we're going to do with the hybrid model. But before we do, there's some bookkeeping stuff that we need to do. You have a homework assignment that we need to turn in today. So why don't you grab your binders, grab that assignment up out of there. We will look at this. While you're in your binder, you may as well grab a blank sheet of paper you can take notes on. Then also grab your periodic tables out of your binders as well. And guys, while you're doing that, I will unlock the submission form so that you can do this now. So this is the subatomic particles assignment and responses, and turn this on and let that save. And we are now good to go. Okay. So, guys, again, while you're in your binders, you may as well just gather up everything you need. So you need the homework assignment that is due today. You need your periodic tables freed from your binders because you're going to need them as a reference today. And then, guys, in addition to that, you're going to need some note-taking materials. While you're getting settled and re-engaging with this homework, this is actually our next homework assignment. You can't do this yet. I know it looks similar to what you have in front of you, but it couldn't be any more different. So we will look over this assignment. Then we'll calendar for a while and make sure you guys are all caught up, and answer any questions that you might have, and then we'll go from there. All right. Then let me get you this one as well. Okay, perfect. Oh gosh, sorry. All right, here we go. Okay, how you doing? Good. Did you have a good weekend? Anything eventful? Which is a victory at some point. All right, there you go. All right. So, guys, let's do this. And as we do, I want to sort of talk you through some ideas about some sort of commonalities that you need to be picking up on relative to this assignment. So let me grab my writing utensils and make this big again. And then, guys, let's talk. So I know we haven't looked at the calendar yet. We'll talk more about when I will see you next. But, guys, you will be coming back the next time I see you, which is actually on Friday, to the unit test. So this will be the last day of this unit. We're going to come back to the test on Friday. And I'll just tell you right now, guys, this is the first page of the test. It's a little bit different because there's a little bit more you need to learn about this. But guys, there are some fundamentals that I want to share with you just to sort of clear this up as you're even thinking about the test on Friday. So guys, when you start thinking about things that you should be checking, first of all, this. In the column when you're abbreviating these elements, guys, please be really careful. It's always capital letter first, and then if there is a second letter, it's always lowercase. So be sure you're doing that right. Then, guys, remember that the atomic number, which is the big number in blue on our periodic table, the atomic number always tells us the number of protons. So, guys, as you're grading this, these two columns should be exactly the same the whole way down. So as you're looking this over, you may want to let your eyes scan down those two columns. And, guys, make sure that those two columns are always the same. Then, guys, once you've done that, these two columns should also be the same. So the atomic number, the number of protons, and the number of electrons should be the same. Now, this is the thought. These will always be equal. The atomic number tells us the number of protons. guys, what you're going to find out today is that in this assignment, those two numbers are the same because we've said that the number of electrons and protons are equal because that creates no charge. The charge is balanced. You're going to find out today that doesn't have to be the case. So you're going to find out that these are not necessarily the same, although in this assignment they are the same. And then the other thing, guys, that you need to keep track of is that the atomic mass is the number of protons and the number of neutrons. So that number on the periodic table is actually the red number, is the number of protons and the number of neutrons. And so if we take the atomic mass and subtract the atomic number, that's A minus Z. That gives us the number of neutrons. And we'll talk more about that today as well. So guys, any questions about this first page of the assignment? Yeah, please.
Why is the zinc abbreviation AN?
Because it's a typo. Yeah, and honestly, James, this is a PDF that I created a couple years ago, and I lost the original file. And so to go back and change that, I'd have to go back and edit the entire thing. And so where's that at? Is it near the bottom? Oh, it's right here. Yeah, that should be a Z. Sorry, that's just my bad. So, guys, other questions or things on the front page of this you need to talk about? You guys all okay? Okay. So then, guys, I believe there's the back to this, yep, which looks like this. This is a retelling of all of the information that we talked about relative to how these elements got developed. Remember, it goes Big Bang, huge clouds of hydrogen come together, fusion in stars, heavier elements, that fizzles out at iron, then the star explodes, it becomes a supernova, that gets us past iron, creating all the elements up until uranium. Then we talk about all these weird analogies about how small the nucleus is, and we go on from there, and how dense the nucleus is. So, guys, any questions about any of this stuff? Y'all okay? Okay, so let's do this. If you'd like to grab your phones really quickly, and if you would like to record this assignment is done, if it is, I'm more than happy to give you a second to do that. We don't have a ton of material to cover today. So guys, if you want to grab your phone and grab the calendar on your phone and access this and enter it, I'm more than happy to give you a minute. Otherwise, guys, don't put this homework assignment away. Hang on to it, because we're actually going to start by talking about this in just a minute. And then again, you need your periodic tables and note-taking materials. So Ryan, you're doing that. Does anybody, yeah. I'm sorry? You need a, do you have a, okay. You just didn't bring anything to write with? Ah. You guys need a second? Annalise, are you recording it? Okay, I'll give you a second to do that. Sounds good. Then, guys, what we'll do is we'll calendar together. And then once we're all settled with the calendar, we've got about 20 to 25 minutes of new material to look at. And you'll have the opportunity to work on your homework. You won't get it done today, but you'll get a good start on it. Did it work okay? Okay, Ryan, are you good? Okay, so guys, with that behind us, if you did not record this assignment because either you didn't want to spend the time or it wasn't done, guys, remember it's due by midnight tonight, so make sure that you do that. Okay, so guys, this then is where we are at for really the remainder of the quarter. I'm going to tell you everything I know. If you have questions about this or any of your other classes, feel free to ask, and I'll do my best to answer. But guys, you know today we're entering into this blended model. It goes A through K, L through Z. Just so you know, as a school, we've actually sort of made a decision that I want to make you aware of. You understand that this A through K and L through Z determines when you come to school. But guys, what we've decided to do is that after 1240, after fourth period, we are going to, by appointment, open the school up to all students. So you guys are all the A through Kers. So maybe imagine on Wednesday it's an L through Z day, but you need to get with a teacher, or you need access to a computer here on campus or something like that. You may actually come to campus after we're done with that, after school. You need to be coming directly to a teacher. You can't just come and wander around. But if you would like access to campus and it's not your day, so long as there's a teacher that you've reached out to and they're expecting you, you're welcome to do that. So, at any rate, guys, here's what we're going to do. Today we're going to wrap up the unit, a little bit of new material, and then you'll have a homework assignment to do that you already have in front of you. But then, guys, in addition to that, there's also this. And let's talk about it now. So, guys, grab this other packet of paper that I gave you that says FET across the top of it. So in addition to the homework assignment that I gave you that looks a lot like the assignment you just graded, guys, you'll also be working on this over the next 4 days. There's no new information on this assignment. Guys, this assignment is functionally really, really good test review. Because what it does is it allows you to interact with all the material that you've been learning in sort of an interactive and interesting kind of way. So guys, in order to do this, you need a computer. You go to the website that's at the top. It's fet.colorado.edu/en/simulations/build-an-atom. Or you could just Google FET build-an-atom and you can click on it from there. And then guys, you'll go through and you'll fill out these pages as you interact with this website. Now guys, I'll tell you right now, there are questions on the test that you're going to take over this unit that are lifted right off of this website. So in order to be prepared for the test on Friday, guys, make sure that you do this. You may want to write this down if you don't think you'll remember. This is due on Friday, and you're going to turn this in to me. This is not a homework assignment. This is an activity. And so, guys, you'll be turning this in to me. If you get home tonight and you're like, oh, crap, I forgot, the activity sheet is posted right there. You can download it if you need another copy. But, guys, you will be turning that in to me on Friday. You'll see that it's mentioned in the study guide for the test, so make sure that you become familiar with that activity because you won't be fully prepared for the test if you haven't done the activity. So again, Monday right now, obviously we're together. Tomorrow, guys, you all will come back for your B day. And then, guys, the 30th, I have no expectations of your time. What I'm doing on Wednesday is the same stuff that I'm doing with you right now, only the other half of the class. So guys, you don't have a screencast to watch. You have no responsibilities to this class on Wednesday, other than you've got the homework assignments that you're going to be working on, but you have no other commitments to this class on Wednesday. Then, guys, Thursday is obviously the B day. That's the second of the rotations. And then, guys, when I see you on Friday, you will be taking the test over this unit. The study guide is posted. We've talked about how to study. And, guys, that test will be the last test, obviously, of second quarter. Then, guys, I will not see you again until the 8th. On the 8th, we will do a lab that actually will not count until second quarter's grade. And so, guys, functionally, when you take that test on Friday, you will be done with first quarter. So you've got the homework assignment that we should have turned in today. You've got the homework assignment that I gave you that we'll be learning about in a minute. Then, guys, you've got that activity, and when you turn in that homework and when you turn in that activity on Friday and then take this test, you are functionally done with first quarter. With that said, if you have any late lab work or activities to turn in, you just need to turn them in before Friday at 11:25. Guys, understand that is a B day, so you won't even be in my room. Just understand anytime, that's the drop dead. That's non-negotiable. I won't take late lab work or late activities from you after Friday at 11:25. And then, guys, we will be remediating this second test, and those remediation opportunities are down here. But, guys, I'll talk with you more about this on Friday. We're going to do remediation a little bit differently. I will not have you fill out the essential analysis sheet. I will actually do it for you, and I will post a document with your student number on it that will tell you whether or not you qualify for remediation, simply because we don't have time for you to do the evaluation and then still be involved in remediation. So I'll take care of that. And guys, that'll be the end of the quarter. We don't yet know what's going on the 3 days before fall break. This is the day this will be our 2-week mark right there. That's the point where we'll evaluate and figure out whether or not we get to come back to school like more everybody or not. That'll be on Friday. So guys, that's where we're at. I know that was a lot of information, but the bottom line is today's new material, Friday's the test. Coming back after, when I see you again, we'll do a lab. And if you're all caught up and in sync and don't need to remediate, you're functionally done with this class on Friday. This Friday, once you're done with the test. Again, late labs stuff on the 9th, and then remediation the following week. So, guys, any questions about this, for this or any other class, calendar stuff, how we're managing all of this? You guys okay? You're good? Okay. So, guys, one other thing to mention, and this is going to be difficult, but I need to sort of share this with you. So, relative to your grades for first quarter, guys, this is going to require, I think, some communication. It always requires communication, but this quarter more than ever. So I know that as the quarter begins to wrap up, you start to look at your grades and you're like, oh my gosh, and I need to talk to Knappenberger and I'm concerned about my grade. And guys, we'll talk more about this, as we get closer to the end of the quarter. But guys, if you're concerned about your grade, please come and talk with me. I would be more than happy to sit down and discuss this with you. I'll be honest with you, I'm nervous about first quarter grades. And guys, I'm a firm believer in the idea that your grades are a representation of what you know and the quality of the work that you do. But the problem is I'm not completely convinced that your grades for first quarter will necessarily be a reflection of that for all of you, simply because the quarter's been so weird. So guys, if you would like to talk with me about your grade, make an appointment. Don't come in here last minute with tears in your eyes. Because if you would like to talk about your grade, I would love to do that. No guarantees, but I would love to sit down and chat with you. Handle that well, make an appointment. We'll find an isolated time to sit down. But guys, again, I'm a little unsettled with first quarter just because of how nutty it's been. And if you'd like to talk, please let me know. So, guys, are we done? Are we all good? Anything y'all need to discuss? You're okay? Okay. So, guys, we've got about 20 or 25 minutes of material that we're going to talk about. And then we are going to, we'll give you some time to work on your homework. So let me quit out of this. Let me grab a hold of this. So guys, grab your note-taking materials. Everything. You need your periodic tables, note-taking materials, and then also your homework from last time. And what we're going to do is we're going to use your homework assignment from today as a jumping off point to what we're going to learn. So the homework assignment we graded today is where we're going to start. But guys, these are the topics for your notes today. Ions, isotopes, and average atomic mass. The date today is the 28th. So if you would like to date your notes, the date is the 28th. These are the things we're going to talk about today. And again, guys, we're looking at probably 25 minutes of things that we need to talk about, and then you'll have, maybe a little more, but then you'll have some time to work on your homework. You guys all set? Okay, so, yeah. I do. Yeah, it's actually right here. All right. So guys, what you're going to find is this. As we dig into this new material, you're going to find that actually what we're doing is we're going to be answering some questions. So guys, this is the homework that you've got in front of you. And I want to make sure you're really clear on what's going on here so that you also then understand the questions that we're going to be asking and answering. So guys, as we were grading the homework, we said that these two columns are always the same. We said that the atomic number is always the number of protons. And guys, that will always be the case. But then we said this. We also said that the number of protons is equal to the number of electrons. Guys, understand that's about to change. So make sure you're clear on this. The atomic number is always the number of protons. But guys, in this assignment, the only reason the protons and electrons were the same is because if you have the same positives as negatives, they cancel out and you end up with no charge. Guys, today that's going to change. So the first thing we're going to talk about is what happens if the number of protons and electrons are not the same. And we'll discuss that. We'll talk about how we think about that. Then guys, the second thing that we're going to talk about today is actually focusing on the atomic mass. So guys, you should remember that the atomic mass is the number of protons and neutrons. But guys, this brings up a problem. So if you remember, protons have a mass of 1 and neutrons have a mass of 1. But guys, if you look on the periodic table, you'll notice that most of the masses on the periodic table are not whole numbers. They're decimals. And guys, if you understand what's going on, that shouldn't make any sense. If a proton weighs 1 AMU, and if a neutron weighs 1 AMU, when you add up a bunch of ones, you should get whole numbers. But guys, most of these are not whole number masses. So guys, the second thing that we're going to talk about today is why are these masses not whole numbers? So guys, that is our laundry list of stuff for today. First of all, what happens if protons are not equal to electrons? And then second of all, why are the atomic masses not whole numbers? And once we understand both of those ideas, we'll be all done for the day, and you can start working on your homework. So guys, question number 1 first. What if the protons and the electrons are not the same? And guys, the answer is simply this. They turn into ions. So guys, this is where you're going to start your notes, right here, and we're going to talk about ions. Again, we're answering the question, what if the protons and the electrons are not the same? And if they're not the same, guys, if we've got an imbalance in protons and electrons, we end up with ions, which by definition are atoms with a charge. They can be positive, they can be negative. But if the protons and the electrons are not the same, we end up with atoms with a charge. So guys, for example this, and you don't need to necessarily write this down, but here's the idea. So imagine that let's take a carbon atom. So guys, find carbon on your periodic table. How many protons does carbon have? Do you find carbon? 6. So guys, carbon is element number 6, so carbon has 6 protons. Now guys, be careful. If you couldn't answer that question because you couldn't find carbon, that's one thing. If you couldn't answer that question because you don't know how to figure out how many protons carbon has, guys, you found a gap in your understanding. So if this is a carbon atom, carbon's got 6 protons. Now guys, how many neutrons does a carbon atom have? Well, in order to figure that out, as you know from the homework, guys, we look up the mass. Carbon has a mass that rounds to 12, so 12 minus 6 is 6, and that gives us 6 neutrons in the middle of a carbon atom. Now guys, how many electrons does carbon have? Well, carbon has got 6 electrons. So this is a carbon atom as we find it typically in nature. Now the trick is this. We are now going to make this carbon with a charge. So guys, say for example, we want to give carbon a -1 charge. So guys, watch close. If we want to give carbon a -1 charge, what we're going to do is we are going to add an electron to carbon, which is really easy to do. But guys, we add an electron to carbon, and now we have 7 electrons, 6 protons. We have 1 extra negative charge, and this then becomes carbon with a -1 charge. Now guys, what about this? What if we want to go in the other direction? What if we want to give carbon a positive charge? So guys, imagine that we want to make this carbon +1. So guys, if we want to give it a +1 charge, we come along and we add a neutron, and now it's got, a proton, and now it's got one more positive than negative, and that would be carbon with a +1 charge, except for one really big problem. What's wrong with doing that? Go ahead. It's not carbon anymore. This is now nitrogen. So guys, the trick is this. What I just did is actually wrong. In order to give a carbon atom a +1 charge, we don't add a proton, because if we did, it's no longer carbon. So how can we give this a positive charge and still keep it carbon? Take away an electron, and now we've got 5 electrons, and that is now carbon with a +1 charge. So guys, if this isn't tracking for you, you may want to jot a note to yourself. When you form ions, you never muck around with the protons. You always adjust the electrons. So guys, with that said, this can go in one of 2 directions. And these things have names. So we're going to name them one at a time. These are words and ideas that you need to know. So guys, the first term is what is called an anion. This is not an anion. It's 2 hard syllables. This is called an anion. And guys, anions are negatively charged ions, like carbon with a -1 charge. So as we just figured out, in order to give an atom a negative charge, we formed these by gaining electrons, and therefore we consider these things to be electron-rich. So guys, if those are the negatively charged ions, not surprisingly, we also have a name for the positively charged ions, and those are what are called cations. Again, this is 2 hard syllables. These are not called cations. They are called cations. But guys, these are the positively charged ions. And as we just learned, the positively charged ions are not formed by adding protons. They are formed by removing electrons, and therefore they are electron deficient. You'll find out in the next unit that when, well, actually 2 units away, that when you get a positive and a negative ion together, they stick, and they form what we call salts. But we'll get into that later. All right, so guys, here's where we are. What happens when protons and electrons are not the same? Then we have an atom with a charge. We call that an ion. If it's an anion, that thing is formed by adding electrons. It's negatively charged. It's electron-rich. If we remove electrons, that forms a positively charged ion, which we call a cation, and these things are electron deficient. So guys, what I'm going to do is I'm going to give you a couple seconds to make sure you're clear on this. Once you're satisfied that your questions are answered, then we'll go on from there. But let's try a couple just to make sure you're okay. So guys, right next in your notes, if you would do this. Go ahead and draw a big circle. Draw yourself a little circle. The big circle is the electron cloud. The little circle is the nucleus. Some of you are realizing this is not drawn to scale, because if it was, the nucleus would be the size of a marble and the electron cloud would be the size of a football stadium. That's a whole nother thought. But guys, for calcium with a +2 charge, please write in the number of protons, neutrons, and electrons for a calcium atom. By the way, guys, calcium's over on the left, like 4 down. 4 down? Okay. Look at me, number 20. So guys, let's take a shot at this and then see what we can do for questions. So guys, calcium is element number 20. That always tells us that there are 20 protons in the nucleus. If it's not 20, it's not calcium. Now guys, let's finish up the nucleus before we move on. So calcium has a mass of 40.078. That rounds to 40. So 40 minus 20 gives us 20 neutrons. Then guys, calcium with no charge also would then have 20 electrons. But now we need to make this calcium with a +2 charge. I know that this is backwards, but the logic is if we want a +2 charge, we've got to take 2 electrons away because the electrons are negative. And so 18 electrons would then give us 2 more positives than negatives, and this would make calcium with the +2 charge. Is that okay? Because what questions do we need to talk about? You all right with that? Does that sit okay? Okay. So let's try one more. So guys, down here, let's go the other direction. Let's go negative. Let's try nitrogen. It's element number 7. Let's try nitrogen with a -3 charge. All right. So guys, let's take a swing at this. So as I told you, nitrogen is element number 7. If it's not 7, it's not nitrogen. Then we need to know the number of neutrons. Nitrogen is element or has a mass of 14 and change. That rounds to 14. So 14 minus 7 is 7. Then guys, nitrogen in an uncharged state has 7 electrons. To make it -3, we add 3. And that would give us 10 electrons orbiting around that nucleus for nitrogen, and that would make then nitrogen with a -3 charge. So guys, what about questions there? Then let me ask you a question. How are you going to remember that +2 means take away 2, and -3 means add 3? Because that's the tricky bit on these. People, if you're going to make a mistake, people tend to get those backwards. You're going to have, and maybe you just understand it well enough to know. But guys, if not, you're going to have to put something together in your brain that will allow you to realize that these are backwards. Again, because electrons are negative. Now guys, if you're interested, and I think some of you might be, here's the thing that's interesting to me. Calcium with a +2 charge has 18 electrons. That gives it the same electron structure as argon. Guys, nitrogen with the -3 charge has 10 electrons. That gives it the same electron structure as neon. And guys, it turns out that when atoms gain and lose electrons, they actually do it in ways that give them the electron structure of these elements over here. These are called the noble gases, and they're actually super stable. And so guys, when we add and remove electrons, most of the time it happens in such a way that they take on the electron structures of the noble gases. But we'll talk more about that later. So guys, are we done with ions? Because if you're satisfied with ions, we're now going to move on to the next and last thing that we need to talk about today, which is isotopes. So guys, anything there with ions you want to clarify before we move on? You guys okay? All right. Here we go. So guys, the next thing, the last thing we need to talk about then are isotopes. So guys, what I'd like to do is I'd like to define this for you, and then I'd like to chat with you about it for a minute and help you understand what this is about. So guys, remember the second question that we're answering today is why are the masses on the periodic table not whole numbers? And so guys, the answer to that question is because they exist as different isotopes. So what is an isotope? Well, guys, isotopes are atoms of an element with different masses. So guys, to help you understand this, we are going to again turn our attention to the element carbon. So guys, I think some of you understand this, but guys, you understand that the guts of your pencil are actually not made of lead? You guys know that? That actually lead causes birth defects and brain damage in little kids, and actually for us too. It's just that our brains aren't developing fast enough for it to be a problem. But guys, years ago, they actually made lead illegal in pencils. You can still buy them in art supply houses, but to the general public, this is not lead anymore. This is graphite, and graphite is actually made of carbon. Guys, this is actually what the graphite inside your pencil looks like. And you know this, that if you tap your pencil on the desk, this stuff shatters, right? Well, guys, the reason is because when you tap your pencil on the desk, what you're actually doing is disrupting these weak attractions between the sheets of graphite, and when these start to shift, they shatter, and your pencil graphite actually breaks apart. So guys, these rings are very stable. It's called graphene, and then they're very weak on this plane. So when you tap it, you're actually shattering these sheets apart, and that's why graphite is so weak. Well, guys, here's the thing that we're going to talk about today about carbon and about graphite. Guys, it turns out that inside your pencils, all of those atoms are actually made of lead. Here's the thing that's weird. They don't all weigh the same. That if you could take all the carbon atoms in the guts of your pencil, and if you could sort them into piles, you would find that while they are all carbon atoms, they don't all weigh the same. So guys, take a second if you would, and scratch this in your notes, and we're going to talk about it. Guys, once you're done scratching these three circles, find carbon on your periodic table and drink in the stuff that you know about carbon simply from that information on the table. And then we're going to talk more specifically about where this information comes from. So guys, this then is the idea. If you could take the carbon that is inside your pencil, and if you could separate it by weight, you would find that while they are all carbon atoms, they don't all weigh the same. And so guys, let's talk about how they're different. So guys, again, there are three different weights of carbon inside any sample of carbon. So guys, because these are all carbon atoms, they all have 6 protons. So all of the atoms in your pencil are carbon, therefore they all have 6 protons. Now guys, here's the difference, and I want to make sure I get my numbers right. Okay, so guys, the difference is this. If you could take the atoms inside your pencil, and if you could separate them, you would find out that some of those carbon atoms have 6 neutrons. But they don't all have 6 neutrons. Some of them, you know what? Actually, that's not right. Some of these actually, the first one is 5. Some of them have 5 neutrons, some of them have 6 neutrons, and some of them actually have 8 neutrons. So guys, here's the question. What do these 3 atoms of carbon have in common? Well, they're all carbon. They all have 6 neutrons. But guys, how are they different? Well, they weigh different amounts. Because they have different neutrons, they weigh differently. And so we give these things names based upon their weight. So guys, this is carbon, but what would that carbon atom weigh? How much does an atom weigh that's got 6 protons and 5 neutrons? 6 plus 5 is 11. So guys, this is what is called carbon 11. Now, what about a carbon atom that's got 6 protons and 6 neutrons? Well, that weighs 12. And then guys, some of you have probably heard of this one. What does an atom weigh that's got 6 protons and 8 neutrons? Well, 6 plus 8 is 14. Hey guys, some of you have probably heard of carbon-14 because it's radioactive. And it turns out that we can actually figure out how old things are based upon the amount of carbon-14 that's in them, because over time, as it's radioactive, it breaks apart. And by knowing how much is in there, we can actually figure out how old something is. So guys, this is then the trick. If we take all the atoms of carbon that are inside of our pencil, here's what we'd find out. Some of these atoms weigh 11, some of these atoms weigh 12, and some of these atoms weigh 14. Now guys, with that said, here's then the $10,000 question. Where does the number in red come from? So the number in red is like 12.0, is it 11? So guys, where do you suppose that number comes from? So we've got some that weighs 11, some that weighs 12, some that weighs 14. And all of those different weights of carbon are present in carbon, like inside our pencil. So where does the mass 12.011 come from? Guys, it's the average. They take the mass of carbon-11 times how much of its carbon-11, the mass of carbon-12 times how much of its carbon-12, and how much of its carbon-14, and they add those all up, and it's just like calculating your GPA. How many A's did you get times 4? How many B's did you get times 3? How many C's did you get times 2? Add all those up, divide by your total number of classes, and you end up with your GPA. Guys, this is exactly the same thing. How much of this weighs 11? How much of it weighs 12? How much of it weighs 14? Add them all up, divide by 3, and that's where that number comes from on the periodic table. It is a weighted average of all the different isotopes that exist. You get the idea? Okay, so guys, this then is what you need to understand about these ideas of isotopes. So guys, it goes like this. Isotopes differ, their masses differ because they have different numbers of neutrons. But guys, this is the thing you got to understand. It's not like carbon-12 is really carbon and carbon-11 and carbon-14 are mutants. Guys, all of these are fully carbon atoms. There is no correct isotope of an element. Guys, instead, all of the atoms of an element are isotopes of each other, and they all behave chemically exactly the same. So guys, let me show you another example. I'll let you finish writing and then I'll share it with you. So guys, neon, for example. If you find neon on the periodic table, you'll find that it's element number 10. What's its mass? Is it in the 20s? Okay, so 20. So guys, neon is element number 10 with a mass of 20. Now, guys, please don't think that all elements have 3 different isotopes. But guys, this is actually the 3 isotopes of neon that exist. You'll notice that they all have 10 protons, therefore they're all neon. If they didn't have 10 protons, they'd be something else. But guys, neon also exists as 3 isotopes. Neon 20, neon 21, neon 22. The only difference is the number of neutrons that they have. Neon 20 has 10, neon 21 has 11, and then neon 22 has 12. And then, guys, that mass that's on the periodic table, the number in red, 20 point whatever it is, guys, that number is the weighted average of these isotopes. So we've got some that's neon 20, some that's neon 21, some that's neon 22, and it's not a third each. But when they take the weighted average, they find that the average mass of neon is 20.17 and so on. So, guys, that's the idea behind isotopes. So anything there you need clarification on. You guys good? Okay, so this then is what you've got to be able to do with that. Once you're settled on this, you're going to have some time to work on your homework. So, guys, similar to what we did before, please scratch this down and figure out what is carbon-13 made of. Guys, notice the little elevated 13 right there. That tells you the mass of the nitrogen. So guys, figure out what nitrogen-13 is made of. Guys, you'll notice that these are actually even easier than the things that we've been doing before. Because now you don't have to go to the periodic table to figure out the mass, and you don't have to round. Simply what this is saying is use 13 as the mass of nitrogen. So guys, let's take a swing at this. We know that nitrogen is element number 7. So in order to be nitrogen, this has got to have 7 protons. Now guys, you'll notice that this does not have a charge. So the number of electrons is the same as the number of protons. So that would be 7 electrons. Now we've got to figure out how many neutrons. And to do that, it's the mass minus the atomic number. The mass is 13 minus the atomic number, which is 7. That would give that 6 neutrons. So guys, the only difference here is now instead of looking up the mass and using the average off the periodic table, you simply use the mass that's given. So guys, let's try another one. Oxygen with a mass of 17. You'll notice that there's 2 ways we can write this. We can do it with a number there, or if we write out the name of the element, then the mass is separated from the name of the element with a dash. And guys, oxygen is element number 8 if you're having a hard time finding it. All right, so let's take a swing at this. So guys, oxygen is element number 8. If it's not 8, it's not oxygen. Then we need electrons. This doesn't have a charge, so that would also be 8. And then guys, to figure out neutrons, it's just 17 minus 8, which is 9. So the oxygen 17 atom has 9 neutrons in it to give it a mass of 17. So guys, we are done with the new ideas that you need to understand. Also, everything that you need to know for this unit for Friday's test. So guys, anything you need clarification on with ions or isotopes? We okay? Okay. So guys, what I'd like to do then is this. And I don't know that you need to necessarily write this down, but guys, this is what your homework looks like. If you allow your eye to glance at that homework sheet, guys, this is an example. It's not right off your homework, but it's an example of what your homework looks like. So guys, because of the mess that we're in with broken schedules and things like that, I'm just going to be really upfront with you. The first, can I just steal this? This is the first page of the test. Not these examples, but guys, when you sit down to the test on Friday, this is exactly what the first page of the test is going to look like. Also, this is the only essential on the test. And you understand what that means. Remember, essentials are the things that you have to know in order to move forward. And guys, this is it. This is the guts of the test. So, what I'd like to do is I'd like to show you a couple examples of what these look like, because they do get a little tricky. And then, guys, the remainder of the day will be yours to work on this homework. So again, this is not out of the homework, but guys, if you're starting on the homework, let me strongly encourage you to join this so you don't mix up the little bits. So guys, the first example, they give us the abbreviation Mg. So we write out the name, that would be magnesium. Then guys, we find magnesium on the periodic table. Magnesium is element number 12, and then I believe its mass is 24.3, so that rounds to 24. So guys, based upon that information, we then know the number of protons. Please remember that these are always the same. Always the same. Then guys, we need to know the number of neutrons. This is always A minus Z. 24 minus 12 is 12. And now guys, we've got to be careful. Magnesium, in its uncharged state, has the same number of protons as electrons. That would be 12. But now we need to give it a +2 charge. So we're going to take 2 electrons away, and that gives us 10. Clarification on that. Then let's keep going. Guys, the next one is lead 209. Notice, what does this 209 tell us? It tells us use a mass that is not the average. Guys, if you look up lead on the periodic table, it's element number 82. You'll notice that it has an average mass of 207. When they give us something like this, this is telling us do not use the 207. Use the mass that is indicated. In this case, that's 209. But then, guys, notice what we do with this. When we write the abbreviation for lead is PB, big P, little b. And then, guys, we write the mass right here. So if it is an isotope that is not the average, then you have to write the mass up above it. Then, guys, this is element 82. That means it's got 82 protons. It does not have a charge, so it's got 82 electrons. And then to figure out the number of neutrons, it's A minus Z, which, if my math isn't failing me, is 127 neutrons. Now, guys, let's do the last one. And this one's a little bit crazy. This is as hard as this can get. So the last one is aluminum. So, guys, let's turn to the periodic table. Aluminum is element number 13, and it has an average mass of 27. So aluminum is element number 13, and again, it has an average mass of 27. But you're going, wait a minute, it says right here the mass is 25. Yeah, So what it's telling you is look at an isotope other than the average. And guys, when it does that, all sorts of things happen. So first of all, this is aluminum, but it's aluminum with a mass of 25. We need to indicate that we are not using the average mass off the periodic table. But that 25 not only goes there, it also goes here. So aluminum 25. Now guys, the number of protons is always 13, or it's not aluminum. Then to come up with the number of neutrons, it's atomic mass minus atomic number, so this is 12. But then, gang, you'll notice that they also told us how many electrons. If this was neutral, then aluminum would have 13 electrons, the same as protons. But it's not. It's got 10 electrons. That means we've got 3 extra electrons, and that gives this thing a charge of -3. Notice, guys, that the charge goes here, but it does not go in the name. So, gang, there's obviously a lot here to keep track of. Yeah? Oh, poop. Is that right? James, think through that with me. There's 3 extra positives. Thank you. I'm sorry. 3 extra positives than negatives. That's +3. Sorry. Yeah, you're absolutely right. Thanks for catching that. Is that okay, guys? +3. 13 protons, 10 electrons, 3 extra positives. Thanks. So, guys, this is the kind of stuff that you're going to see represented in that homework assignment. So again, guys, the idea is this. We've got today to work on this. We will review this on Friday. We will record it through a Google form on Friday. Then, guys, over the next 5 days, you have this PhET activity to work on. Access this website, work through this. Beautiful review for the test. And again, guys, some of the questions on here you will see again on the test. The study guide is posted for the test. And guys, the test again will be on Friday. So the remainder of the day is yours. I would encourage you to get cooking on this thing. I will put the answers up on the wall. Guys, wrap this up. James, I need to talk with you for a minute. Alex, I need to talk with you for a minute. But guys, go ahead and get started. I'll print the answers, and then we'll regroup in just a moment.